we're going to finish the day with Anton Sosulnikov and Haaziq Farook with a K, not a C, and not a Q. How embarrassing, guys, seriously. Pixel Artworks, and we're going to go from Puma to Nike, and a really impressive, large-scale project they did for Nike at the London Eye, featuring 16 interactive treadmill setups. So thanks for sharing that with us.
Thanks, Isabel. Just make enough room for me. Hello, everyone. We made it. Thanks for joining us. Here today for the last presentation. Whilst we get set up, by way of introduction, my name's Haaziq Farook, and I'm Senior Technical Director at Pixel Artworks, and I'm here with Anton, who's plugging in, creative technologist. And I was just to say, I've been working alongside TouchDesigner boffins such as Anton and a few others in the crowd here. I'll shout out Richard, Jack Webber, Ollie, and for nearly a decade now, and I'm humbled to be up here, so thank you so much, and shout out Derivative and all the community for having us. I'll hand over to Anton in a few minutes, but first, I'll do a quick background to the project we're looking at today, and then I'll outline a bit of the technical design. And almost ready. Yep. There you go. Cool. Nice. So this talks about how we deployed 16 installations in one single day. And should I cut the mouse? Sure. Thanks. And a little bit of the background of the project was Pixel Artworks and our client North 6 earlier this year, we launched a one-night Skyline takeover campaign for Nike's new shoe. And part of it was this massive interactive experience at London Eye. And our main brief was to deploy 32 identical interactive installs. That's one for each pod in the London Eye, which then got scaled down to 16 for various reasons. And the experience was a 20-minute running game where you had to run on an actual treadmill. And they wanted real-time visuals as well as reactive lighting. And then from the data that we collected from the treadmill, they wanted a scoring system. There were loads of challenges to this, as you can imagine, but the key ones that impacted our design choices were that no technicians were allowed in any of the pods. So everything just had to work as soon as you plugged it in. The wheel had to keep rotating. So we've worked on the Eye a few times before, but never did they ever request it keep spinning. So it basically meant if someone had an issue with a pod, it was inaccessible to us, so it had to work without fail. And then we only had one day. So there's so many dependencies: mounting the treadmill, gaining power, testing each pod, having about 8 to 10 other people inside at the same time, wrapping vinyl and building sets and electricians. So we had to be in and out. Filming crew. God, yeah. So I'll play a little clip of the entire campaign, and you can catch some glimpses of the running activation, hopefully. No audio? I hear it somewhere.
The game is in trouble. I've been in my depth for the piece of the puzzle. I got it for real. Still keep me going. I wake up and hustle. You won't see me buckle. I've been in the field. Man of the town. You've been in your fields. I'm adjusting this crown.
Cool. So how do we do it? So the journey began with a bit of an R&D sprint where we took delivery of a few treadmills and we started to look into potential sensor solutions to measure footfall impact. So we tested things like microphones and accelerometers and load cells, and we found that all that data came in and cleaning it up was quite tricky, and we had a lot of interference. So what we found was the risk of setting all these thresholds and then it being different between each pod was quite high. So that would mean we would need to calibrate each of the pods on site, which wasn't viable. So we ultimately ruled out all those sensors. So we ended up deciding on using the existing Hall effect sensor inside the treadmill. So we literally unplugged it from what it was plugged into and then hooked it up to a digital pulse counter, which then gave us data to calibrate within Touch. So all we had to do was hook it up and mount that small little device underneath the treadmill, and we were good to go. And what it meant was that the reactivity was now based on speed and acceleration and not footfall impacts, which we found was the best compromise for interaction and ease of integration, because it meant that we could be reliable here with the data coming in, and we didn't have to worry about false data as it simply measured pulses on the treadmill belt as it spun around. And then inside the pod, we had to consider and focus on a small rack profile so we could have all our kit in a small cabinet and that our rack could power on automatically. So we had to make sure all show critical equipment was able to power on, boot up, and launch so that you had no other further input to switch it all on. TouchDesigner machine itself actually worked on a small form factor Windows-based machine, and the project was optimized to run on integrated graphics, so nothing too heavy for this one. So here's an overview diagram. Oh, no, not this one. But this is a little visual of the setup that we had in the pod. So we had a bunch of LED batten lights surrounding. We had the treadmill itself, which was mechanical, so it wasn't powered by electricity. And then we had a screen which showcased the real-time visuals, and our rack was hidden in front of the treadmill in a small little cabinet. So here's a little overview diagram of the system, and with that, I'll hand over to Anton to talk you through the TouchDesigner. Thank you.
Cool, thank you. Thank you. Right. Move like this. Hi, hello everyone. Oops. Right, so what do we have? So we have a whole sense reader. 4 minutes. We have 4 minutes. Oh my God. Okay, okay.
Sorry, I spoke too slow.
No worries. Probably it's time to turn on the TouchDesigner then, right? Of course, like the main hero. Yeah. Well, we have whole sensor reader connect to like via Ethernet to TouchDesigner. We have Stream Deck buttons. Yeah, just like a small one. 3 here's some like simulator for this thing, and yeah, which just like connect via USB. And we had the BitFocus companion that converts messages from Stream Deck into OSC messages. Then like some mumbo jumbo inside the TouchDesigner, of course, and then it just spits out like video, audio, and ArtNet stream. So the whole project, quite simple. I tried to make it simple. Consists of 3 parts: input, core, and output. Input, yeah, it processes the like sensors data. Core, responsible for the whole like game logic side of it, and output components, they all about the content that is based on like internal variables, so sort of triggers and that stuff. Right. So we have to skip something. Well, the sensor input, I think quite important stuff. The one small device that has just showed before, this digital counter that basically, well, like it detects impulse on its inputs, and then it like sends a UDP packet with a counter in it with incremented value. So TouchDesigner can parse this message, then it detects the change in its like counter value, and then every time the counter value is changed, we see the pulse inside TouchDesigner. That's how we got the whole sensor like analog pulse into digital pulse inside TouchDesigner. Then we calculated the real like world speed. Like yeah, let's try like some simulate at least. We also had a small panic button in case I don't know like experience doesn't work like for any reason. So the staff could just like run the simulator experience for the runner. And so we have incoming pulses. We just count the number of them inside like within the time range, convert the number of pulses like per second. Then we need to like understand like what distance actually this pulse represents. So that's why we measured the running surface of the treadmill, and then we also counted the number of magnets that are hidden there. That what gave us like exact distance between magnets, and then knowing the pulse per seconds and knowing meters per pulse, you can like get meters per second immediately, and then basically convert it to whatever you want, like miles per hour or kilometers per hour and that stuff. So yeah, that was like an important, I think, part of the app design, because initially, like I thought, okay, whenever we can just use some pulses to configure all the app, but using the like real speed actually allowed us to be really like flexible with all the thresholds and like tweaking and tuning the experience, because of course like people don't understand like what is like pulse from a treadmill. They understand like, oh yeah, I can run with like 9 kilometers per hour. So that's why, yeah, it was important thing we then could be, yeah, let's say like this threshold was set up at 5 kilometers per hour, like low, like below this, we like won't just like detect a running experience at all, for example. So output. This is like a small tweak we had to make because actually like the hard power cycle didn't allow us to store a portrait mode in the Windows for like various reasons. So that's why we kind of like rotated the app in the TouchDesigner. Video output, which is like single screen app, basically one HDMI output, very easy. Bunch of content, just like prepared some like text and numbers and thunders that you can see here. They are composed via shader, which is also responsible for creating this gauge effect. Well, if I start from the beginning, yeah, you see this black bar running vertically. This is like a indicator for kind of like your strict speed that you got multiply points or whatever. So the faster you run, the quicker this thing is filled up. And this shader basically inverts colors of the incoming content based on the vertical coordinate. And yeah, it composes all this stuff together. Like audio, it's extremely simple. It just like plays audio files in the parallel process. So yeah, it can sound smoothly without any like cracks and things. Light output was kind of like I tried to use similar approach. So all the content is like either pre-baked videos or some like top generators, and then there is a system to convert this textures into ArtNet output. All this like based on 3 steps. First one, there's a CSV table which can be edited by like technicians or like anybody else, which has all information about devices that we use inside the pod. So it's a number of pixels, their DMX addresses, and like their kind of like position inside the pixel map. Then this table is used for building like all necessary data for DMX routing, the output, and for another custom shader that actually aligns incoming texture. Like it samples pixels for each device from the incoming texture and then like aligns them in just like in rows inside the texture, so you have some kind of representation of what each device should actually output, should kind of receive. And then the second step is to convert this structure already like in chop domain into actual DMX channels. And yeah, this is done. This is handled by script chop that uses the DMX routing table as well. So it maps basically like devices from texture into like actual ArtNet channels. Yeah, so it's quite flexible. So yeah, every time we needed to, I don't know, like change the address of any device, you just, I don't know, like upload new CSU table, boom, it's like ready to go. You don't need to do anything else. Yeah, last thing, I hope I'm out of time already, right? Okay, Python, a lot of Python. Yeah, I think it's a good tool for at least like this kind of game experience, because it's much easier to maintain the whole logic within just a couple of Python files, even though there are much more of them here. But the thing is, I used everywhere where I could, I used extensions. So all these companies, they use extensions. They mostly connect via references to like either like their internal nodes or via a thing called PySignal. It's like an external module. You can find it on GitHub, which is kind of like Python-ish implementation of the Qt signal concept. It's a cool thing. It allows you to build very like decoupled components inside TouchDesigner, and yeah, make it like much easier to debug the whole system and to implement like complicated logic. Yeah, for example, we have a Stream Deck component that receives message from buttons. It's very simple, just always say in, and that's it. And the main like thing happens in its extension, which is very simple as well. So the only thing it does, it receives the message, it validates if the message is like correct, and then it emits a signal. That's it. It does nothing about the game state. It doesn't know anything at all about treadmill or something like that. So yeah, very simple. I can copy and paste this one into like other projects, and it will work there. But Event Manager, this one is like the main component of the whole app. This thing, it knows what it needs to like receive messages and stuff like that. So it subscribes to the Stream Deck input.
All right. Well, thank you very much, guys. And I'm sure
guys.
you will have a few more conversations and questions, but thank you.
Thank you very much.
Well, that brings us to the end of our programming, our regular programming.